Okay, let's begin this warm-up. Here we have a graph of the derivative of f, y equals f prime of x, and question 1 wants to evaluate the integral from -7 to 5. First thing I did, which I think you probably did as well, was fill in some of these areas. We computed this area to be 6, this area here also to be 6. The triangle below had an area of 3, and this little guy over here had an area of 1. Okay, so now we're going to evaluate the integral. Appealing to geometry, the first triangle is underneath the x-axis, so it's a -6. And then the next one is above the x-axis, and then below, and then above. And so this comes out to be -2 for question 1. In question 2, they want us to find f of 5. So we are going to use the fundamental theorem of calculus, part 2, and I have this information here regarding x is -3, and I'm trying to find f of 5, so I'm going to incorporate both of these x values and take the integral from -3 to 5 of f prime of x dx. By the fundamental theorem of calculus, part 2, that's going to yield the antiderivative at 5 minus the antiderivative at -3. We shall appeal to geometry to compute this, and that'll be the 6 minus 3 plus 1 to give us 4. Next, f of 5, that's the thing we're trying to find, minus f of -3, that is given to be 80. And then we just have to do a little bit of algebra. Adding 80 to both sides, f of 5 is equal to 84. In a similar way, we will find f of -7. I'll take the integral from -7 to -3 f prime of x dx, and of course that's going to be f of -3 minus f of -7. Appealing to geometry here, we have -6. F of -3 was given to be 80. And f of -7 is the very thing we are trying to solve for. Do our arithmetic, and f of -7 is equal to 86. Equivalent to the average value of f prime of x. And you can approach it in either way. Using this way here, average rate of change in f, well, then we use the difference quotient. F of 5 minus f of -7 all over 5 minus a -7. Or, if we do it this way here, the average value of f prime of x, well, then it's the integral from -7 to 5. F prime of x dx divided by the interval 5 minus -7. You can do it either way, but they will both yield a numerator of -2 and a denominator of 12, simplifying to be -1/6. Question 4 wants us to evaluate several expressions. F prime of -1, well, since this is the derivative graph, I have to simply go to -1 and figure out the corresponding y value, and that is going to equal 2. Which is a point on the f prime graph. F double prime at -1, well, since this is f prime of x, f double prime will be the derivative of this graph, so I have to compute the derivative at -1, and if I pick 2 points, I can determine that that slope is going to be -1. Now, f prime at -4, point on the graph at -4, is equal to -3. That's a point on the graph. And f double prime at -4 would be the derivative here, but we see this corner, and since it's a corner, the second derivative of f does not exist. Question 5, f has a local minimum at x equals, well, I'm studying the derivative graph, and if you remember, it's where the derivative goes from negative to positive. That's going to occur here, and that's also going to occur here. So at x equals -3, also x equals 4. because, now it's really important, this is one of the parts that people miss. We want to say that f prime of x equals 0. That's the part people miss. And this is typically the part people remember. F prime of x goes from negative to positive at these x values, as seen here. Next, we want to determine in this final question where f is concave downward. Concave downward is associated with the second derivative being negative. That means the first derivative is decreasing. So that's going to be here. It's also going to be here. And it's also going to be here. So concavity is always expressed with parentheses. So from -7 to -4 in union with -2 to 1 in union with 1 to 2. Notice that I broke it because of this corner here. Technically, the second derivative does not exist at that corner, and so the concavity cannot be described. Reason here, again, is because f double prime of x is less than 0 on this interval. But we could also, as an alternate, some people prefer this one, is to say that f prime of x is decreasing. That's really what you're looking for. So you can use either or both. Hopefully you did well on this warm-up, because the concepts in this warm-up basically are going to drive the entire lesson. This comes from a while ago from chapter 4, but we revisit these now in terms of integrals. So if you understood the warm-up, you are in really good shape for this lesson.